Hi, this is Mrs. Roble. This is part two of the matter, property, and changes. Um, we're continuing on with the video that we last looked at where we were talking about substances. Now, there's something interesting. When you look at substances, we talked about elements. Well, the interesting part is that we can have another piece of matter that could be considered a substance, and that essentially would be a compound. The difference is with substances that are considered compounds, they essentially have unlike atoms. So a compound is still considered a substance, but the difference is it has unlike atoms. Now, these particles may or may not be molecules, and I'm going to show you a couple things that I found in my kitchen. So the first one is domino sugar. So this is the sugar cubes. You may or may not have this in your kitchen, but I happen to have it. And the second type is actually sea salt. So it says fleur de sel. This is may or may not be in your kitchen. So the question is, which of these two is a molecule? Well, you haven't had enough chemistry to know this, but the sugar is actually a molecule. Now, when you look at another type of compound, sorry, I misspoke. Sugar, it has a uniform composition. So if I was to take a cross section of the sugar cube, it should look the same throughout. So it should have the essentially white color that sugar has. Now, when you look at sea salt, I know it's in the container here, but when you open it up, you should essentially see white compounds throughout. Now, there are lots of compounds. If you go to some of the chemical companies that make these compounds, we're talking about many different varieties. So there are lots of different compounds that are either found naturally or are man-made. Okay, so let's look at formulas. Now, there's actually a couple different types of formulas. There's what we call empirical and molecular formulas. So when you're looking at both, the difference between empirical and molecular is that empirical is the simplest ratio of elements. So you're going to see the subscripts that are located in the formula. They're not divisible by a factor. And I'll show you that in a minute here. Whereas molecular formula, this has the exact number and the types of atoms that are found in that substance. And I will give you some examples so that you can tell the difference between the two. Okay, here we go. So we have a series of compounds here. So we have water, sucrose. Sucrose would be in the sugar cubes. Glucose. Glucose is actually a building block of sucrose. And then hydrogen peroxide. Now, if we take a look at water, we have 2 hydrogen and 1 oxygen. If you were to divide 1 into 2, you would still have a remainder. So the empirical formula for water is H2O because you can't necessarily divide 1 into 2 without having a remainder. Now the question here I have is sucrose. We have C12H22O11. Okay, 11 goes into 12, but you have a remainder. So because of that remainder, it's not going to be reduced down by a factor. So the empirical formula for sucrose is C12H22O11. We can't reduce it down to a lower factor. Now looking at glucose, we have C6H12O6. 6 goes into 12 twice. 6 goes into 6 once. So guess what? This does have an empirical formula. And typically we show it with a parentheses here. So the empirical formula for glucose is CH2O because 6 goes into 6 once, and there's an understood 1 there. I'm not putting 1 in there. 6 goes into 12 twice, so I'm putting a subscript of 2, and then 6 goes into 6 once. There's an understood 1 there. And then outside of this parentheses, I'm going to put the number 6. And that represents that this empirical formula times 6 equals the molecular formula. Okay, let's look at H2O, 2. So 2 goes into 2 once, 2 goes into 2 once. So yes, this has a empirical formula. So it's HO. And then outside of the parentheses is a 2. So that represents the fact that 2 times 1 is 2, gives you 2 hydrogen, 2 times 1 oxygen gives you 2. So we're reducing it down to its simplest formula by a factor of 2. So notice that glucose and hydrogen peroxide, the empirical formula is different from the molecular formula. Whereas sucrose and water, because their factors are not divisible by a number, they remain the same. Okay, here we go. So I went into my kitchen and I tried to find 2 mixtures here. Okay, the first one I want to show you is vanilla. The reason why vanilla is a mixture is it contains water, caramel color, vanilla, citric acid, sodium benzoate, ethyl vanillin, and artificial flavor. So notice that there are more than one substances found in this bottle. And if you had to guess, is it an element or a compound? Right, it's full of compounds. Here's another mixture. So this is actually Szechuan pepper. My husband makes this. So he takes sea salt, or coarse sea salt, I should say, and then he takes Szechuan peppercorns and he heats them up together to give you this nice zesty seasoning. And notice that these are both made up of what? Compounds. Now the question is, which of these is homogeneous? So look at homogeneous with me. Homogeneous has to be a mixture of 2 or more substances and they are uniformly mixed. So if you had to guess, which of the 2 would be considered homogeneous? Is it the vanilla or is it the Szechuan pepper? You're right, it's the vanilla. Because when you look at it, notice it's the same throughout. So it's actually considered a solution. So the vanilla is considered a solution. Therefore, the heterogeneous, okay, it's 2 or more substances that are not uniformly mixed. So if I take a cross section of this Szechuan pepper, I'm going to find bits of salt and bits of Szechuan peppercorns. So it's not a uniform mixture, therefore it's heterogeneous. Okay, so this is the last activity that I'm going to have you do with this video. And I'll do the first 2 and then you're going to do the last 3 by yourself. So notice that with this activity here, we're trying to make up a true statement. So if you look at the top here, it says all dogs are animals, but not all animals are dogs. Now we're going to go down to mixtures and solutions. So you're going to choose which word goes first in each blank. So ask you this, are all mixtures solutions, but not all solutions are mixtures? Okay, when you think about it, are all mixtures homogeneous? No, okay. So the opposite has to be true. So all solutions, I'm just doing the abbreviation, are mixtures, but not all mixtures are solutions because we have heterogeneous mixtures and they are not considered solutions. So that statement that we just made is correct. Okay, the next one is elements and substances. So are all elements substances? But not all elements, I'm sorry, not all substances are elements. Yes, that is correct. So all elements are substances, but not all substances are elements. Because we can have a substance that's a compound. So that's why that statement is true.